Welcome. Now I'm going to discuss the second part of lithium aluminum hydrates. In previous class, I have discussed that how this lithium aluminum hydrates react to the polar multiple bonds and polar bonds, and it is not reactive to the non-polar bonds that I have already discussed in the previous class. So today class, I'm going to discuss about the stereochemistry of lithium aluminum hydrates. So if in a compound, if the stereochemistry is mentioned, then how we will tackle that type of problems. So today class, I'll discuss about of the stereochemistry of lithium aluminum hydrates. So before we start this lithium stereochemistry of lithium aluminum hydrates, it is very important to discuss some non-valence systems, some and that is chair form of cyclohexane system. So that we have to discuss. After that, we will discuss the detail about of the stereochemistry of lithium aluminum hydrates. The first topic is non-valence systems. So let's say if we have a molecules, this type of molecules, let's say we have H here, let's say we have the H, and here we have that carbonyl groups. Now if you give any nucleophiles, the nucleophile may be lithium aluminum hydrate. Lithium aluminum hydrate is also type of nucleophile where H minus will attack here. So any nucleophile, if you attack here, and if you do this hydrolysis, then what will happen? This now what will do that? Count the numbering. So always count from this bridging system. So this is a bridge and this is a bridge. So count from here: 1, 2, 3, 4, 5, 6, and 7. So at 7th positions, you look that whether this carbon, this hydrogens, so to this carbonyl groups, this towards this hydrogen is there or any other groups are there. If hydrogen is there, then this is a smaller group, so this nucleophile will attack from this exo positions. Okay, this is called that exo attack. So if it is attacking from this is called that exo attack. So it will do the exo attack, and the product will be that here H, here H, and this is going to be, so nucleophile will attack from here, so exo attack, so nucleophile is here, and H will be, and O minus will be here, and let's say hydrolysis after that is going to be the OH. So this will be the product if the hydrogen is towards this carbonyl groups. Okay, this is the first example. Let's say if we take that next, let's say if we have this group, now let's say here previously we have that here H, now let's say here instead of H, CH3 is there, and here hydrogen is there. Now if you are doing that nucleophiles, and we have this H3O plus. Okay, so now what will happen now? So here we have these carbonyl groups here. So now this will attack either this exo attacks or this attack from this directions. So since now this here we have these methyl groups, and except hydrogens, all are bulky groups. Okay, so except hydrogen, all other group considered as bulky groups. Okay, so here that CH3 is there, so this is a bulky group. So now it will not attack from exo, it will attack from this side. Okay, so how the product will be? The product is like this. So here we have that CS3, here we have H. So this attack is from this below side, so this O will be go here, O minus, and this here will be the nucleophile, and this is going to be the OH. Okay, so if bulky groups other than hydrogens, any other groups which is towards this carbonyl groups, then it will attack. It will not attack exo attack, it will attack from this below sides. Okay, similarly the same examples if we have, let's say, okay, so now previously we are having these carbonyl groups here, now we will do carbonyl groups either can be here or can be here. Okay, any of these places. And now here we have, let's say here we have that H, and let's say we have now also here we have H. So same case. Okay, now if you do that nucleophiles and we giving that hydrolysis, then this will attack from this exo attack, means it will attack from these directions. Okay, so this is again this exo attack. So this is going to be H and H, and this will be nucleophile, and this is going to be that OH. Okay, again the same way, if you have this type of groups, suppose now here we have that CS3 and we have now here H. Now we are doing these nucleophiles, and now we have this H3O plus. So now if you are doing these reactions here now, so here we have this carbonyl groups. So now how it will attack? So here since CH3 group is there, so this is a bulky group, so it will not do this exo attack, it will do from this below sides. Okay, this is prepared and this exo attack is not prepared. So this will be the, here we have that H, here we have CH3, then this will attack from here, so this is going to be OH, and this is going to be the nucleophile. Okay, this is the product. So we can see that either it may be here, it may be here. So whenever we attack from this type, that is called exo attacks. So in this 7th positions, okay, this is 1 starting from here, 1 2 3 4 5 6 and 7. At these 7 positions, whether this CH3 group is there or other than hydrogens, any other group is there, then it will always prepare from this below side, it will not attack from this exo attack. Okay, it will do other than exo attack, that is you can say that is attack from the below sides. Okay, so this is the about of this nonvalent systems. Another system, another typical questions came, that is, let's say if you have these systems here, now suppose if we have here the double bonds is there. Okay, and let's say here we have this methyl groups, carbonyl groups, we have that carbonyl groups here. So now we are giving any nucleophiles, and here we are giving H3O plus. So now from where it will attack? Okay, so now since this is a planar systems, this is sp2 hybridized. sp2 hybridized means a planar systems. So since this is a planar systems, now attack will be, so here we have this hydrogen is there, here we have the hydrogen is there. So since this is a planar system, so this is go to in a plane, so this attack will be always from this sides. Okay, it can be never be from this sides, because here this is a planar system that go into a plane, so this attack will be always from this exo attack. So this will be like this, and here we have that OH, and we have here the nucleophile. Okay, so these are the one way questions may come, that like this typical problems, and we will discuss more while discussing the previous year questions. Now we'll move to that cyclohexane systems, that is in a chair form. Let's say if we have a molecules, this is cyclohexanes in this molecules. Actually this molecule is not exist. Actually this exists in this chair form. This exists in a chair form. This is not exist in this form. This exists in a chair form. So whenever the questions will come, stereochemistry is there with a cyclic system, a cyclohexane system, then first convert into a chair form. After that only solve the stereochemistry related to this type of questions. Okay, so first convert into this chair form. And here what we look, that wherever this above side, this and this and this, okay, so wherever this above side, this is called that axial sides, axial, and this is the equatorial, this is axial. So whichever above means that will be axial, and here down, so this is going to be the axial, and this is the axial, and for this is the axial. Okay, so be careful that these positions are axial, and for this case this is below, so here below will be the axial. Okay, and so wherever this below, that state will be the axial, and this case below, so this is axial, this is axial, this is, wherever this above will be the axial. Okay, this is above. Okay, so this is 3 are axial and these 3 are axial. So we has to memorize, we has to be careful that above which are there, then above will be the axial. This is above will be axial, this is above will be the axial, and below means below will be the axial. Okay, for this case this, and equatorial, for this case this is above, so other than this will be the equatorial. Okay, equatorial, for this will be the equatorial, and for this equatorial will be the dispositions, and for this equatorial will be dispositions, and for this equatorial will be this above positions, and below for this equatorial will be the dispositions. So this in the chair form you can see that, or I can give that by different. Okay, so this will be the equatorial, this is that equatorial, and this is the 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 equatorial. Okay, and these white ones are axial. Okay, these white ones are axial attack or axial positions, and these red ones are, these are equatorial positions. So it has to be careful that these things, and it is very easy to always remember that whatever this above means above which will go, that will be the axial, below means which will go below will be the axial, and for the equatorial, other than that are the equatorial. So if it is a cyclohexane, first convert into the chair form. Okay, so you will look that examples related to this. So before that, let's say if any system is like this, okay, this is the axial chair form of cyclohexanes. Now what happened here, this is that axial, because above means above will be the axial, this is axial, and this is the equatorial. Okay, so you see that nucleophile always prepare to the axial attack. What you see, that nucleophile always prefers to attack from axial. Why? The reasons we will see here. Let's say for this, what will have, this is that axial is there, here hydrogen is there, and this, for this also down, so axial will be here. Okay, I can see here that this is and okay. So now whenever a nucleophile will attack from here, if you attack the nucleophiles, and this nucleophiles, if its axial will be attacked, then for this if it is attacking from this axial positions, for this that the antibonding will be this directions. So this antibonding can be fulfilled from this electrons from here. Okay, so and what we see that CH bond and CC bonds. Okay, and this is the one this is the case 1. Let's say this is the case 1. Now case 2, this chair form let's say that now let's say if you are attacking nucleophiles from equatorial positions. Equatorial positions means this directions. This is the equatorial. Okay, so you are attacking from equatorial. So for this, that antibondings are this direction. This is the antibonding. Okay, and this antibonding, this electron is fulfilled from either these CC bonds, either or from this CC bonds. Okay, this is that parallel to that, which will parallel that will be the fulfilled. So either this will go or this bond will go. This is the CC bonds or this is also CC bond. So here what we see that CC bond is fulfilled to the antibonding of equatorial attack. If we are doing equatorial attack, then it is fulfilled this antibonding by the CC bonds. But if we are attacking from the axial attack, then this antibonding is fulfilled from this CH bonds. So now we say that CH bond and CC bond, we see that CC bond is the stronger. So now it is very clear that so if nucleophile will attack from axial, then that antibonding is fulfilled from this CH bond. So always the nucleophile will prepare to axial attack, not equatorial attack. Okay, so this is the reasons the nucleophile always first preference will be the axial attack. Always prepares to attack from axial side. Okay, so now that axial attack is always first preference, but if there is a 1-3 diaxial interactions is there, then only the axial attack will be not happen. Okay, so what you see that, let's say in this form, let's say we have here, let's say we have that we are giving the nucleophiles, and let's say here 1, 2 and 3. Let's say we have here any CS3 groups, and 1, 2, 3. Here also we have any CS3 group. Okay, now you are doing this nucleophile, then what you see that we look that to count 1, 2, 3. Okay, from this also 1, 2 and 3. So now what you see that at 1, 3, now always look that 1, 3, not 1, 4, not 1, 5, that is 1, 3. 1, 3 diaxial interactions present or not. So here we see that if the nucleophile will attack from this axial, then here nucleophile will come. So at this 1, 2, 3, so 1, 3 here also at this axial, this bulky groups is there. So if at axial positions already a bulky group is there, then that one this axial attack will be not prepared. This will do the equatorial attack. So if that H is there, then this is not a bulky group. On that case, axial attack we can do, but we should look at both the cases. Here also that there should not be any bulky group. There should be any 1-3 diaxial interactions. Here H, but here is CH3 is there. So again 1-3 diaxial interactions is there. If diaxial interactions is present, on that case it will not attack by axial side. It will attack through equatorial attack. Okay, so these things you have to be keep that while you are doing this stereochemistry of cyclohexane systems. Okay, so first Norbornene system we should look that once 7th positions, and for this chair form we will look that 1-3 diaxial interactions is present or not. Okay, so if present, on that case what will do that equatorial attack we will do. Okay, and if absent, then we will do axial attack. Okay, so axial attack is always preferred, but we have to look that whether 1,3 diaxial interactions is present or not. So accordingly, we will do that which attack, either axial or equatorial attack we will do. Okay, so these are the some things about of this chair form. Now we will solve this some examples related to this. Okay, so now in this case we look that if this is a chair form, carbonyl groups is there, and now we are doing a nucleophile. Let's say this is the nucleophiles. Okay, and we seen that this in that is in NMR also I have discussed that this is always exist in a straight form. This is always like this always exists this form. Okay, so whenever it will attack to this group, so it will always attack in the axial attack, because this is just like a hydrogen atoms. So also you see, you look here, here is hydrogen is there, so 1 2 3, here also we have that hydrogen atoms is there, here also you see that 1 2 3, here also hydrogen atom is there. So here that 1 3 axial attack will be the preferred, it will do that axial attack. So axial attack will be prepared. So this will going to be here we are having that C triple bond C H, and here we have that OH. Okay, so this will prepare axial attack, and this is generally 78% we can get. Here 28% minor product will be the equatorial attack if this is this positions. Okay, now if we are doing that CH3 groups, so always remember that if other than hydrogen atoms, on that time we will do that axial attack, but here that CH3 groups we are doing. So if you are doing that CH3 groups, now you look here 1 2 3, this is that 1 2 3, here hydrogen is there, here also hydrogen is there, because this is 1 2 3, but this CH3 groups it will make what, let's say if you are going to attack here, so if we are going to be the CH3, then this is going to be H, this is going to be H, and this is going to be H, and here let's say OH. So again it will do 1 2 3 H and H. Again there will be a repulsions, so the axial attack will be not prepared. So axial attack is prepared if this is also H minus, then we will do that axial attack. But if it's just CH3 minus, then we can't do the axial attack. For this case, this is just like a H, because it is exist in this form. Okay, so there will be no steric hindrance. On that case, this will be 78% and this is 28% nearly. Okay, so this is the major product. But if CH3 minus is there, then it will not attack by axial. Axial attack is not prepared. It will attack the equatorial attack. So that will be here. CH3 will become these sides and OH will be this, because axial interactions will be there. Okay, with this and this axial interactions is present, so we will not do. So this is going to be at least, that is 20%, and this is the 80%. So equatorial attack will be the major product for this case. I am talking about nearly that value maybe varies. Okay, so I think is that this is the major product and this is the minor product. Okay, now if you are doing this phenyl systems to this, so again you will do that. So you will look, this itself is a bulky groups. So if it is a hydrogen, on that case we will look that whether 1 3 diaxial interactions is present or not. But itself this and this itself is a bulky group, so we will not do 1 3 diaxial interactions. We will simply do that equatorial attack, because it will make 1 3 diaxial interactions even with these hydrogen atoms also. Okay, so here this is again a very, so although this is a planar systems, because this is sp2 hybridized, but still it will prepare to equatorial attack, because here the hydrogen is there. If you do this phenyl groups, so here hydrogen is there, so that will do that axial interactions. So this is again, although this is 46 or 38%, or 46 percentage, something somehow that will do. But again, this is a minor product, and this, because this is a planetary system, so that's why a little bit more product it will prepare. But still the major product is equatorial attack will be the major product. So this will be that phenyls, and here we have that OH. Okay, this is that let's say 52 percentage, or this is let's say 42 percentage, then this is going to be the 58 percentage. Similarly, if you have that CH3 CH2 MgBr, so this is the this charge, and this is the positive charge, so this will attack. So this itself is a bulky group, so we will not do 1,3 diazyl interaction, so we will simply do that equatorial attack. Okay, so if you do that axial attack, then you see that here, see here we can look that here CH3 will come, and here we have CH2, so there will be so much diazyl interactions is there. Okay, so this will be very less percentage, let's say something 20 percentage, and equatorial attack, here CH2 CH3, and here we have the D, so this will be the 80 percentage. Okay, so again this will be the axial attack will be the, sorry, equatorial attack will be the major product. Again this axial attack will be the very less. Okay, so what we see here, that if hydrogens are there, on that case, if you are doing that hydrogens on that times, you will do that whether axial attacks or equatorial attacks. Okay, so in this case you can check that whether axial or equatorial attacks, but if it is a nucleophile itself is a bulky groups, on that time always do that equatorial attack. Okay, so for case of lithium aluminum hydride, this is that H minus, it means that this is a not a bulky groups. Now we will do that whether 1,3 diaxial interactions is present or not. But if that nucleophile is itself is a bulky groups, then always do that equatorial attack. So for this case, we will check that 1,3 diaxial interaction is present or not, because our nucleophile will be the very small groups. So first I change these groups to a axial forms, sorry, to a chair form. So here name this 1, 2, 3 and 4. Okay, so change this to this form. Okay, so this shows that this is in the above side, so I will like to do here from, so this is above. Okay, this is 1 and this is 2 and this is 3 and this is 4. Okay, and this is in the below side. Below side means here this is the below equatorial, and for this is the below. Okay, this is actually what it is exist. Okay, so now I change this into a chair form. Now I will do this H minus attack. Okay, so now what you will do, that first preference will be the axial attack. So this is, let's say, okay, so now this is like this, and we have here, and here we have, now here we are attacking this H minus here. So this will do the axial, past preference will be the axial attack. So now what we look here, so here we have that axial positions is there, and here this is already in the axial positions because this is like this is like this. Okay, so for this axial is here preference, and here already axial is used, so I can attack only from here. And if I attack, I has to look that whether 1 3 diaxial interactions is present or not. So 1 2 3, so no diaxial interactions. So 1 2 3, so no diaxial interactions. So this attack from this axial attack. Okay, so axial attack prefer, so past preference is always axial attack. So now this is going to be this H will becomes here, and O, this is breaks, and this is going to be the OH, and this is now change into the again to this cyclohexane form. So this is in above, so I can do this above, means let me do here. So anywhere 1 2 3 and 4, so 1 2 3 4. Okay, so let's say I'm taking 1 here, and this is in the above, and 2 nothing is there, 1 2, and at 3 OH is there at the below sides, so I will do that OH, and this hydrogen is there at the above side at the 4. So this is, so this is the our final product. So first we will convert into the chair form, then we will solve the problems. Okay, this will be the answers for these questions. Now let's solve these examples. For this, first we will change into a chair form. So first I will convert into chair form. So this is again 1 2 3 4 5 6. Okay, so first chair form. Okay, so now this one, at the one case this is above, so let me put here in this directions. Here we have that methyl, so we can put anywhere, and the 1 2 3, so 1 2 and 3, and this is also in the above side. So above means this is axial, and for this case this is going to be like this. Okay, in this way it is exist. Now we are giving that lithium aluminum hydrides, it means this is H minus. Okay, so this H minus will always first preference will be the axial attack, because itself is not a bulky group, so we look that 1 3 diaxial interactions is present or not. If it is not present, then always axial attack we will do. Okay, so now see that if I attack from here, then this is axial attack is free here, axial position is free here, or for this case axial attack, axial position is already filled, so I will do that here. So now I have to look at whether 1 3 diaxial present or not, 1 3 diaxial interactions present or not. So I will start from here, 1 2 and 3. Okay, another case 1 2 and 1 1, from here we will start wherever 1 2 and 3. Okay, so from where this is there, from that we will start where we want to do that attack, from that count. Okay, 1 2 3, but here this is there, but this is in the equatorial. If it is axial, then 1 3 diaxial interactions is will be happen, but here this is in equatorial, so it will easily we can do that 1 3 diaxial interactions, because if this methyl is in the below sides, on that case 1 3 diaxial interactions will happen, but this is in the above, so here that 1 3 diaxial interactions is not present, so we can do that 1 3 diaxial interactions. So this will be that, and here we will do the attack here we will get the H, and this is already CH3 is there, and if we will do, then if you attack from here, then this is going to like this, so this is going to be O minus, or if you after that hydrolysis, this is going to be OH. So this again change into the chair form, so change into cyclohexane form, so this is going to be like this, So name here 1, 2, 3, 4, 5 and 6. So at 1 that CH is there, that is in the above. So draw this, and at 2 OH is there, that is also in the above. So draw this, and this H that is at the down. This is like that. So this is also you can write like this. In the exam it will write, because H they will not mention, only for CH3 and for OH they will mention. Okay, this is the final product for this questions. Okay, so now we will move to the next questions, that is this. For this case, again convert into this in the chair form. So first naming this 1, 2, 3. Okay, so at 1 methyl is there, and that is in the down. Okay, so methyl is down, so let me down here methyl, and 1, 2, 3. 2 and 3 that is in the above. Okay, so this is above, so this is like this, this is like this. Okay, so now we have that lithium aluminum hydride. Okay, so now you see that here that axial position is already fulfilled. Here axial position is there, but if you do the axial positions, then 1, 2, 3, 1, 3 diaxial interactions is there. So if 1, 3 diaxial interactions is there, you can check other form also. Okay, so other form of this is, let's say I can do this one like this. So let me take that methyl is in the down. Okay, so can I put here methyl down here? Let me check here, methyl is down, and 2, 3 we have this, and that is also in the above. Okay, so 2, 3, this is 1, 2 and 3. Okay, that is in the above. So one is here, another is like this. Likewise it is there. Okay, so now we have this lithium aluminum, that is hydrogen minus. Now look that any axial attack is possible or not. So this axial attack is already fulfilled, and here axial attack is there. Yes, here axial attack chances is there. So now count this, any 1, 3 diaxial interaction is present or not. So you want to attack from here, so 1, 2, 3, 1, 3 diaxial interactions is present, because this is also in axial positions. And 1, 2, 3, although here is not there, but here again we have the diaxial interactions. So we can check all other forms also, all other form in the sense that now try to take we have taken here. Now let me take here this methyl groups. Now if I take this methyl groups, and methyl groups is in the down, so down is, that is here methyl groups, and 2 and 3. Okay, so at 2 and 3, so that is in the above. Above means this is, this type is there. So now for this axial attack is there. Yes, here if you do this, here the axial attack is there. So if I attack from here, then any 1, 3 diaxial interactions is present or not? For this, there 2, 3. Okay, 1, 2, 3. Yes, axial interactions is here not present. So here we can do that axial attack. So we can check that all other possibility. So always like to put this here, here, here. This is down, so that's why I put here down. Okay, so by making this down, you can check or everywhere whether anywhere this is possibility or not. So again here, if you do here, then here if you attack axial attack, then we can do that, because here this is absent. So 1, 3 diaxial interactions also not there, so we can do here. Okay, so this will be like this, and this will attack from here. So this is going to be H, and this is going to be the OH, and this methyl, here is the methyl. So this is okay. So this methyl is in the down. So let me put here CS3, and this H is down again, and this OH is in the above. So this will be the product. So whenever this lithium aluminum hydride or any that is less bulky groups, that is not a bulky groups nucleophile are there, always search for 1,3 diaxial interactions. Wherever 1,3 diaxial interactions is possible, take the all the possibility. Okay, so if here in this case 1,3 diaxial interactions was there, but if you take like this, then here that 1,3 diaxial interactions is not there. So in this way you can in this case there is a possibility of axial attack, then do the axial attack. So always look that if nucleophile is less bulky, search for wherever the chances to attack the axial attack. Okay, this will be the final product for these questions. And for these questions, must convert into a axial chair form. So chair form will be okay. So now here is above is there, above methyl is there, and at the same time down is hydrogen is there. Okay, and this is 1 2 3 and 4. So 1 2 3 and at 4. So 3 and 4, that O is there, and that is in the above side. So this will be the O and this is the O. So likewise it there. So now we will do that any axial attack is possible or not. Okay, because with okay, pH S and A plus. So now the reagent is different. So now the reagent different, and this reagent is a bulky reagent. So now it is a very good, very easy that you always do the equatorial attack. We don't need to sort the axial attack. Okay, because this itself is a bulky reagent. So look here. So if I attack to this, then 1 2 3. Okay, so still there is a 1,3 diaxial interactions is possible, and if I attack from here, then again there is a, so since this is itself is a bulky group, so we no need to look for axial attack. So we will simply solve it. So this will be do the axial attack. The equatorial attack we will do. So equatorial attack means I will attack from this side. So if I attack from this side, then this is going to be the down. So I will do that attack here. This will comes to the downs, and this is going to be the SPH. Okay, so this is here again here CS3, and again here we have that hydrogens. So if you convert it into that forms, then we can say that this is going to be this. Okay, so this CS3 is above, so again we do that this CS3 is in above, and this hydrogen is down, so you can do again this is a down. So now this is attack 1 2 3. So 1 2 sorry 1 2 3. So 1 2 and 3. So in this come that is comes to be the down. So SPH, and this is also at 3 and 4. This is also at the down. So this will be the answers for these questions. Okay. Now if we have these questions here, so this again we will change into that chair form. So this 1 2 3. Okay, so let's take this here. Then 1 2 3, 1 2 3 here the double bond is there. So now if you are attacking this Br, this is Br and Dr, so this will be do that, then this will going to be like this. Okay, so here will be Br and here will be the Br. Okay, and this here, this is that CH3. So now again Br minus will comes here. So we will look that this Br is a less bulky group. So look that if it is in this case this is already in the axial, so here we can attack, then there, that's 1 2 3. So here we can do that equatorial attack, so axial attack we can do here. Okay, so here will be that here Br and here Br and here this groups. So this, if you convert it into the chair form again, then this, and one Br is like this CS3, and this is 1 and 2 and 3. So this is 1 2 3. So one is above, that is Br, another is down. This will be the answers for these questions. Now the last questions from this is this. Now first convert into yes, if this type of a question is asked, then BrOH minus. Okay, so first convert into this chair form. Okay, so this is above CH3 and this hydrogen is down. So 1 2 3 and 4. Okay, so 1 2 3 and 4. So 3 4 double bond is there. Okay, now BrOH. So this BrOH, this is delta plus and delta minus. So this again the same things will happen. Here what happened, this Br will comes. Okay, so here again that Br will comes. So this Br will be let's say Br is like this. Okay, so if Br will come like this, although here also anyone can do. So this is because this is a planar systems. So planar system means that Br can join from any sides. Okay, now this OH minus will be this is a less bulky groups, so it will look that where axial attack. So here 1 2 3. Okay, for this case if you do the axial attack, and here this is 1 2 3. So it will do that. You can make this. Okay, so this here we can make this Br and here. So why? Because here if you do attack from this axial attack, then there's no chances, but if you attack from here, then axial attack is possible. So this is going to be, so here we looked at the possibility of axial attack. Accordingly we can change this picture. Okay, so now it will do axial attack, then here OH, and here we are getting that Br. Okay, here we have that CH3 and here are the H. So if we convert into this, then okay, so this is above, so you make this CH3, and here 1 2 3, at the 3 we have that Br. So here again we have that Br, and 3 4 we have that, here we have that OH. This is the final product. Okay, so today after this, in next class we will discuss more questions. Thank you.